Today on Teardown, I'll be dismantling an NEC VT470 digital video projector in the classical sense using screwdrivers. So there's another dead video projector that my friend VJ Bry gave me, and it's past being bad, so we're going to take it apart for the optics. Now, this video projector was made in about 2005, so I'm betting it's going to be a 3-way LCD, and it definitely has 2000s aesthetics to it. Quite rounded, as I say here, DNX Pixelworks. I've never heard of DNX Pixelworks, so it couldn't have been too good. Probably hype words. No. Wow, look at that flex. Oh, I got an idea. Time for some entertainment you don't get on other channels. Oh, it really is. This thing's a trampoline. That's fun. Alright, let's pop the unit apart. I'm going to take out all the screws we can find and go at it from there. See what's inside. Yeah, let's see if there's any screws in the, what I'm guessing is the lamp compartment. Looks like just 2 screws holding the lamp in. Yeah, little lamp. It maybe about the 1000 lumen range, a little bit more. Pretty common lamp type. Here we have in the back about 1 screw by the video in. Probably does absolutely nothing, but we're going to take it out anyway. Okay, I think all the screws are out. Go ahead and try and take the top off. Oh, I see why they have this raised now. It's to make room for all the capacitors on the main board. Since they decided to put the switches right on top instead of making a separate board for the user interface. Well, that's what they got going on there. Alright, makes sense now. Okay, next step is to, at this point, remove the main board. I'm going to go ahead and undo all these connections. We'll get that up and out of the way. And of course, get to the optical train, because that is what I'm most interested in. And if you watch my channel, I think that is probably your primary interest as well. Of course, that may be truthful, given that you might be a returning viewer. You probably already know what's inside of here, and you might see something interesting anyway. One more. Yes, it is all of them. Oh, I see. Okay, so it's held together by that connector there. Is that removable, or is that soldered on? Oh, that is one piece. I see. I see. Well, there's only one way to handle this. I lie, but it's a fun way to handle it. everything is a quick disconnector if you're knowing how to talk to the connection properly. Alright. What we got here? Pixel works. Pixel works. Oh, it looks like just in-house branding of some new whiz-bang, probably encoder function, something on the projector. I have no idea. Look, it's just name branding. TM copyright nonsense. Doesn't actually mean it's better. It just means that it has a fancy name. Alright, let's get into the optical train now that we're here. Okay, so this is nice. So I noticed on these, it looks like there's sections where you can move up and out the pieces of polarizing film inside of the projector in case the polarizing film gets burned and starts to color the image wrong. You have dark spots on the sides of the image. You can change your polarizing film, fix it. That's the red one. This is going to be the one for the green. Probably the one for the blue here. Oh no, I see. Okay, so that's marked blue. So blue, green, and red. Nice. And we can get into the rest of the optical train now, I think. Maybe. Alright, in this area we have the beam homogenizer and the dual axes polarizing plate. Let me pull that out. Okay, so this section here, it does two things. Oh, we have two lenslet arrays. This is a lenslet array here, and then underneath there's another lenslet array, a multi-lens array. And what they do is they homogenize the output of the lamp. And what it does is it makes the intensity more even. So that means that the light that's in the middle area of the image is going to be the same brightness as the light that's on the outer areas of the image. So it just makes it more even. Otherwise it would look kind of like a flashlight and you'd have uneven brightness on your screen. And then we have an optic here in the front, and not a lot of people talk about this optic. It's a little bit of a mystery, and I'm not exactly sure what it's called, and I just call it a dual axis polarizing plate. And go over how that works. You know, because it's an LCD device, of course you need polarized light in order for it to function correctly. So if you take a look at this optic, you'll see that there are bars here in metal blocking some of the optic. If I flip it around, now it seems like those bars are gone. If you take a look at the edge of this particular optic, you'll notice that it's put together with independent pieces of glass that are bars going this way, and there are 45-degree cuts that join each one of those optics together, and they're all glued together. On the surface, you'll also notice that there are these strips. So there's a strip, there's a strip, there's a strip. And those are polarizing filters that are on top of this optic. And how this optic works is it works by reflecting some of the light and therefore polarizing it, kind of like lasers do with a Brewster window. And then it also polarizes some of the light with the polarizing filters. Now, the light that comes in that gets reflected will come in, shoot down, reflect off the edge, shoot 90 degrees, and come on out. And then the ones that are polarized with these polarizing filters, they go directly through the slits. So light comes in, hits a slit, it's either passed right through or it reflects off. If it reflects off and then out, it'll be polarized in the up and down position like this. And if it passes through, then it's going to be polarized by the polarizing filters in the horizontal like this. So this is a source of light that is polarized into axes. That's a pretty neat optic. And of course that plays in with the polarizing filters that I removed earlier. These help polarize the light as well. And in fact, if you take this and you rotate that in front of that optic, you'll see that there is a change. Not much of a change this way, I don't think. Let's see. Yeah, because you're getting both portions of the light. But here you can definitely see a change. Alright, continuing on. So, the output of the lamp comes in through this section here. It gets homogenized and it gets polarized on two axes, and it hits this optic here, which is a lens, and that focuses the light down. Wow, that got blasted. Look at that. That coating is trashed. It's beautiful, but it's also trashed. But anyway, as I said, it condenses the output of the lamp down, and then that condensed light goes into the optical chamber portion here, which is where the dichroic pieces of glass are. So those will split the white light into its constituent colors, red, green, and blue. So this is the blue right here. Then we got a dichroic piece of glass right here, and what that does is it reflects blue components of the light up this way, and that reflects off this first surface mirror here, and then through this lens into the polarizer, one of these, to give it a little bit more of a definite polarization, through the LCD panel here, and then into the X cube, the dichroic X cube. So this one we can pull out, and then the rest of the light that's not blue passes right through. So if you look at it through here, you can see yellow. It's because the green and the red portions of light end up going through this dichroic filter here. Let's take a look at this dichroic filter glass here, and what this will do is it will reflect the green portion of the light upwards through the LCD core here, and it will pass the red component through. So if we take a look at the light that's reflected off, it's in the greens and the blues, and the light that passes through at that angle is in the reds. Now, and once again, each one of those have their own polarizer that goes in front of the LCD panel. Take out these lenses. Most of the lenses are positive meniscus biconvex. That means that both surfaces are round on the outside and not sunk in, and they're magnifiers. So, and these are, and that a lot of these optics are pretty toes. Look at that, a beautiful color, but oh, woof. Maybe some cleaning will resurrect them back to life. Nice AR coating, so probably broadband. AR stands for anti-reflection, in case you don't know. You know, the first surface mirror right here is in pretty good condition. Another biconvex lens here. Hey, I know who I'm sending that to. I know somebody in need of a lens of just that size and focal distance, and they will appreciate it. And I got another first surface mirror here in this corner, and that takes in, it reflects the red light up here. This reflects the red light out, and then this way. Now, two 45-degree mirrors, making two 90-degree bounces. Oh, here we go. Easy does it. Nice reverse surface mirror. Don't break, don't break, don't break, don't break. Oh, that's helpful. You know what? You're going to be of assistance whether you like it or not. There you go. Now we can remove that. Nice. Okay. And now we have the three-way LCD core to figure out how to, well, get out. I spoke too soon. It is out. Nice little focusing and zoom assembly here. One is focus and one is zoom. And how these lens carriers work is that they have lens carriers on the inside. One lens, two lens, three lens, and as this rotates, each lens in this carrier assembly will move according to those notches. So they'll change their focal distance from one another, position relative to one another, and that'll change the properties of the optical train. Go ahead, can I take that off? I think if I would have rotated enough, whatever is preventing that to be moved will undo itself, and it has undone itself. Ta-da! Oh, that was damaging. I'll just glue it back together eventually. Okay, so if I rotate this, you can see that those lenses move up and down along with the positions inside of that ring. Now they got that down to an engineering science. Let's separate that from the X cube and the LCD panels. You can see some of the discolorization in the anti-reflective coating on that lens as well. It's seen better days. It's seen better days. Alright, we're going to take off the LCD panels. Alright, so here are the three LCD panels. There's one for each color, red, green, and blue. And they're actually marked for a reason. They don't exactly have the same polarization characteristics just because of the way the whole unit works. So they kind of have to be individually labeled for that reason, I believe. These are really interesting to kind of mess around with. For example, if you hold it up to your eye, you can see some effects like a diffraction grading. You can see the different rainbow kind of colors over here. Zoom in. Yeah, minor diffraction effects. And if you shine a laser through it, you'll get similar effects where you see multiple dots. Turn off the light. So just like that. So pretty neat to have around if you're interested in things that are cool with lasers. But yeah, those are just little LCD panels. And then we're going to get to the Dichroic X cube. Go ahead and take that apart, get inside. Oh, yeah, I have the secondary polarizers. So we have polarizers like this, and each one of those LCD panels has 2 polarizers in addition to the effects of the dual axis polarizing plate and the polarizing properties of the Dichroic Trichroic X cube. So each one of these sits in between 2 polarizing optics like that, and you'll see that this actually has polarization characteristics itself. As I said, that's why they're identified with different stickers. So if I stick this one in, you can see changes kind of purpley color. Let's go ahead and put another one in. Here's a green. Not quite such a drastic change as the other one. Go ahead and see the last one. Yeah, a little darker. But anyway, just like a calculator screen or an LCD display, or like a laptop would have 2 pieces of polarizing film on each side of the liquid crystal layer, so do these, and that's a big part of how these work. Let's take apart this a little bit more, and hopefully I can show you something else that's interesting. Glue test. Alright, I'm going to hit that with the heat gun too. And usually a little bit of heat helps break these off. That didn't completely go as planned. Got it. Alright, so here is the Dichroic Trichroic X cube. You can actually see it is marked. But anyway, these are a little bit of an interesting device and a little misunderstood. So I'm going to kind of explain to you how these work. Because they work kind of like a polarized beam splitting cube and a dichroic piece of glass all at the same point in time. So I'm going to point out a couple of things. So if I hold the cube like this, you'll see that there's a blue reflection off the cube. I'm going to rotate it then 90 degrees, and you'll see that there isn't much color that comes off. Now, let's take a look at a piece of dichroic glass. Let's pull from the projector. So you take this, and I'm going to hold it at that angle, and you'll notice that that is almost the same color that's being reflected off at that angle, and that is because there is a dichroic layer along this portion of the cube. So what about the red color that you see in one of these cubes? Where does that come from? Now, if I hold this piece of glass in the same manner, so there's the blue, and if I rotate it like this, you'll see that, hey, there are red seeds there. Well, what's going on? Well, the light is coming in this way, and it's being filtered by this piece of dichroic layer in there, and it's resulting in the reds and oranges being left over. So that's where those colors come from. And the reason why it gets reflected up is because a total internal reflection, different densities of thin film optics in here, and the polarization characteristics of the cube are made to reflect the red off at that angle more effectively. Let's go ahead and grab a piece of polarizing film, and I can show you that polarization has a lot to do with this optic as well. Well, if I take and turn that, you can see that the cube changes. So yeah, so how these work is you got the blue light that comes in, say this way, it gets reflected off the dichroic layer and out this way. Meanwhile, the red that comes in this way is filtered by that same dichroic layer on a different axis. And then the green actually comes in for that 45 degrees to each one of those axes. It looks 90 degrees, but optics are a little weird. But anyway, so it comes in and it all blends together. And green is actually almost untouched completely by the cube. So yeah, I love these little things. They're great with lasers and stuff. Let me show you something else that's a little quirky. And that has to do with these. It looks like these are the right optics for it. So sometimes you'll get lucky bonus optics, and these have to do with changing the polarization of the light, and they're called either wave rotator plates or wave retarder plates. So let's see what we have here. We have two optics here. Now let's see if we're lucky. And I want to point out something real quick. If I take a normal piece of glass and I put it between two polarizers like this, that around, and not make it dark. If I put the piece of glass in between there, it does nothing. It doesn't change the polarization at all. Has zero effect. Sometimes you'll run into these really thin materials inside of the LCD projectors. If I put this in, you'll notice that that glass changes as well. And I think that's because it's some kind of quartz, but it makes a great laser optic. In fact, just to show you this, I'm going to completely remove the polarizing filter that's on there and show you that it is just the material that it's on itself as well that has that effect. Okay, so that's the actual glass right there. As I said, I think it's some kind of quartz. I'm not quite sure, but I'll put that in between the polarizing films, and you'll see that, yeah, has a very distinct effect on the polarization of the light that goes through it. It's interesting. It's not a polarizing film. Yeah, I think it's a wave rotator plate. Let me show you something else that's different about this optic too, and it affects laser light. So if I say I have a polarizing film right here, I'm going to put that there, and I'm going to shoot the laser through. Okay, that mostly passes. Let's rotate it till it's blocked. Okay, it is blocked there. Now if I take and put this there, rotate it, I can change how the laser light passes through. Oh, you really can't see it, can you? Turn down the light. Alright. Blocked. Let's rotate it till it's blocked again. There we go. And then yeah, pretty handy optic to have around if you mess around with lasers, because this will let you change the polarization of your laser beam. Yeah. Another positive meniscus lens. Looks to be plano convex. Put that there. So let's finish removing this. This looks to be the power supply. Oh, that's the lamp driver. There we go. Oh, now it comes apart. Alright, so this is the little lamp inverter ballast thing. Let's pop that apart. Looks like it doesn't even need any screws to be removed. No, it doesn't. That's nice. Yeah, pretty standard one. It looks like here's your pulse network side for the igniting, and we'll probably have a full bridge driver in this section here. Let's find out. Do we have a full bridge driver? I think we do. Well, 3 optocouplers for interfacing with the motherboard. That's pretty common. 3 optocouplers is standard, but I don't see 4 MOSFETs on that little board, so that means most likely this is a half bridge driven transformer. MOSFETs. Yeah. 1, 2. I've seen better. This should be the main power supply. Yeah, there's the infrared receiver. And there's the power supply. Come on. That's a nice little one. Oh, what do we have here? Looks like mains in, filtering 2 metal oxide varistors, an NTC thermistor of some sorts, rectification, full bridge rectifier in here, high side switching MOSFETs, diode, transformer, big filter capacitor, and low side diodes and smoothing. A pretty standard switch mode power supply. And the reason why this capacitor is so big is because after they rectify the mains, they basically just have a DC tap right there, right off this capacitor, sending high voltage DC out. So that needs to be pretty well smoothed. What else do we have here? Is that it? I think maybe we have a few fans underneath. Let's see if I have a few fans underneath. The more fans, the better, because they make me cool. Look at this gratuitous use of plastic. Nice blower motor. And one thing you'll notice is the better the projector, and often the older the projector, the better the fans are in them. I'll take a mid-2000s projector fan over a modern day projector fan. Yeah, that's a NIDEC. These are very common in video projectors. There's also probably another NIDEC. Yep. Take that one off too. So it looks like 3 fans. Let me see. 1, 2, 3, 4. 4 fans. Not bad. Yeah, the scrap collectors are going to love me this week. Look at something else besides energy drink cans. Caffeines are going to kill me. Alright, well, I spoke too soon. We have 5 fans? 5 fans. Uno, dos, tres, cuatro. Nope. I misspoke. But I aced my Spanish test. Alright, let's get everything all organized and go through what I got. So what was in this projector worth keeping? Well, let's take a look at the parts I've salvaged. Starting with the optics, I have the 3 LCD panels. I'm not really sure what to use these things in. I don't know how to drive them, but eventually that might change. Until then, I use them as diffraction gratings. So I put them over the camera or over my eyes and see different spectra, or over a laser to make multiple dots. I have 3 first surface mirrors right here, 2 dichroic glass filters, which are handy for joining different color lights together or splitting them apart. I also have the beam homogenizer, and I kept this assembly together just like that, so I can kind of show you how this works. Now, I'll turn off the light, and I'll get this little light out here, and you can see that it's brighter in the center than it is on the outside. So what the beam homogenizer does is it kind of splits the light apart, and then it refocuses the light, and you can get a more even distribution. So it works better one way than the other, but you can see the squares, and at one point the squares kind of come together and make a very even lighting distribution. So it's kind of how those work. See if this is the right way. No, I think it was the other way around. But yeah, that's kind of how it works. And it's just a little LED flashlight I'm shining in there. It makes cool patterns though. Yeah, totally an optical assembly worth keeping. If not for anything else, demonstrative purposes. Pulled out the lenses. All the lenses are positive meniscus, most of them being plano, biconvex, and some of them are plano convex. Like this is plano convex. And plano just means it's flat on one side, so plane. Got these polarizing films, and all of these are on the same substrate that do the polarization rotating. So very useful for lasers or combining lasers that use a PBS cube and make a very cheap alternative to using a quarter wave rotator plate if needed. What else? Got this, the dual axis polarizer plate. I'll hold this up to the camera and try and show you a little bit more of how this affects things. I want to rock this optic back and forth, and you don't see much change down here. But if I flip it over now you see that they change, so every other one. So yeah, polarizing optic, interesting optic, but also kind of useless for what I do. Got the Dichroic XQ. This is handy for joining together 3 different colors or splitting them apart or working with joining lasers together. Although the lasers do have a preference for the polarization angle that they enter in. So for example, you want to have the polarization for the green side to side like this, and then use a vertical polarization for the red and the blue to optimize the performance of the cube with lasers. Let's see. Sorry, ran out of recording room. Moving on. And then fans. 4 fans in this projector. It's a pretty nice fan right here. What are you rated? Half an amp. 6 watts. Not bad for a fan like that. Yeah. That's about it for this projector teardown. Got some cool things. Little thermistors too. Yeah. That was fun. Well, I hope you enjoyed. And as always, stay tuned for more.